Hello students, in the previous lectures we discussed the basics of alternating current and how to find the average value for off cycle and full cycle time durations for the time varying function, and then we discussed AC with resistor and RMS value. Yes, by the continuation of the topic, so today we are going to discuss AC with inductor. Okay. So now, as I said earlier, our ultimate aim is to find out the expression for current if the voltage is given. So now please see that this is inductor of inductance L, which is connected to the alternating source. So this is inductor of inductance value L, as I hope that you know all the things. So the applied voltage is V is equal to V naught as sine omega t. So for ideal inductor, that means we can assume that the resistance of the coil is considered to be 0 for ideal case. Therefore, for ideal situation, for ideal case I can say that the applied EMF voltage is appeared as to be induced EMF in the coil due to the self induction. Okay, so therefore the induced EMF that should be equal to applied voltage for ideal case. This is nothing but we know that L into di by dt, as we are already studied. Okay, so that is equal to V naught sine omega t. V naught what children? Sine omega t. So now you please take this. Our aim is always to find out the current equation only. Therefore, I can write that V naught by L into sine omega t into dt. Okay, so this is the case. Now I am going to integrate this equation. Therefore, the total current I is equal to V naught by L integral sine omega t into what children? dt. We know that sine integration is minus cos omega t by omega. So therefore, I can write that V naught by L. So V naught by L, this integration is minus cos omega t divided by what children? Omega. You know the formula. I hope that you must learn the basic mathematics. Okay, so now you please see that. Yeah, so therefore I is equal to I can write that as to be is minus V naught divided by L omega into cos omega t. That cos theta can be written as sin 90 minus theta. Why we have to write this as to be why we need to convert this one from the cos function to sin function means to compare the phase differences. Okay, so when we are finding the phase difference, you try to make that both the functions. For example, here we are going to compare the phase difference of voltage and the current equation, means try to convert that both are maybe in the same trigonometric function. So now this can be written as, so therefore minus V naught by L omega, this is what children? Is sine of 90 minus theta, that is sine 90 minus omega t. And we know that sine is a odd function. Sine of minus theta equal to what children? Minus sine theta. So by using this idea, I can write this I is equal to V naught divided by L omega. This minus is taken inside. Therefore, I can write that sine of omega t minus what children? Pi by 2. So yes, now as we said earlier that this is the dimensionless quantity, just a mere number. So left side is current dimension, means this should have the current dimension. Therefore, I is equal to I naught sine omega t minus what children? Pi by 2. What children? Pi by 2. So this is the expression for the current, where we have to find out I naught. I naught is nothing but what children? Voltage by L omega, that is V naught by L omega. Since this is the Ohm's law, I is equal to V by R, so this term L omega should have the dimension of resistance. So this is considered to be a dimension of resistance. So I can call it as that has to be XL, inductive reactance. Sir, JM sir, what is the difference between resistance and reactance? Or means resistance does not depends on frequency, whereas reactance depends on frequency of the applied voltage. Okay, so now please see that. So from this I can say that I naught is equal to what children? V naught by XL, that is equal to V naught by what, children? L omega. This is the amplitude of the current, where the term that is called inductive reactance. Inductive what, children? Inductive reactance. It's inductive reactance. So what is that, children? XL is equal to L omega. In the previous video, we discussed the basics of the alternating current. There omega equal to 2 pi f. Therefore, I can write that L into 2 pi f. So this is the, as I said, from the Ohm's law, this is the dimension of resistance. Therefore, unit for XL is nothing but ohm only. So unit of that one is what, children? Ohm, because it's like or play the role of resistance. But we are not calling that as to be resistance, because it will be a frequency independence. Okay, this is called inductive reactance. Now I am going to draw the graph for that, how this XL depends on the L value and omega value. So when you draw the graph between either omega or frequency, here has to be L. So there, see that XL is proportional to L and omega. Therefore, the graph will be a what, children? A straight line what? The graph will be a straight line one. This is the information what we are getting. The another thing is, the another point related to inductive reactance is, we see that as for XL value for DC, we know that when we discuss the difference between AC and DC, there we said that for frequency of the DC source will be 0. Therefore, XL will be 0. Frequency will be 0. Therefore, XL equal to 0. Therefore, XL equal to what, children? 0. But in the case of AC, FAC, that is nothing but F, which is not equal to 0. Therefore, as we said, XL is proportional to omega or proportional to frequency. Yes. So what is the meaning of XL equal to 0, JMs or means? You just see that this XL equal to 0, it represents that whenever DC source is connected, here we are talking about AC. Suppose if you are connecting the battery, whenever DC source is connected, say this is the inductor, this is the inductor which is connected with some DC source, DC power supply. So at this case, since frequency will be 0, this inductor can be replaced by, just like XL equal to 0 means this inductor will act as just like a connecting wire, because we are assuming that for connecting wires whose resistance are very less or approximated as to be 0. So this is nothing but, the inductor is nothing but equivalent to just like a connecting wire. So this diagram is equivalent to just like a connecting wire. So this is the position of the inductor, but L is replaced by just like a connecting wire. So it looks like this. That means the inductor is considered as to be a short circuit when the DC source is connected in this. But here, as we said, there is a dependence of frequency and L values. So this is the information about what, children? Inductive reactance unit is ohm only. And another one is, as we discussed as a resistor, AC with resistor, here also I am going to draw the graph. One is called voltage graph, which is vary with respect to time. So here you may take that has to be either voltage or current. Okay. So now please see that here I can take either voltage or what, children? Current. But you always, for our easy reference, you just keep that that voltage has to be a sine curve. Voltage has to be a sine curve. So you just see that when you just see when time is 0, sine 0 is 0, so V equal to 0. But when time is 0, sine minus 90 degree is there. That means that the value will be -1, therefore minus I naught. So when voltage is 0, the current will be negative maximum. So you just go according to that. When voltage is positive maximum, and then the current will be 0. When it is 0, it will be positive maximum. And vice versa. So like that it will go. Okay, children. So now this is the graph for current. This is the variation of graph for what, children? Current in the this is current graph The solid line one is voltage graph. So how to draw the graph? You no need to memorize. Just take these two equations and you please find out this. And as we said, this is the phase factor of voltage and this is the phase factor of inductor. Therefore, we just see that pi v equal to what, children? Yes, pi v. Yes, you just see that the phase factor of voltage is omega t and the phase factor of current is omega t minus pi by 2. Omega t minus what, children? Pi by 2. So therefore, you just see that here we can say that delta pi. Delta pi means what, children? You just find out, for example, pi v minus pi I. That is our wish. Either you can subtract from a voltage phase or current phase. That is our wish. So when you subtract this omega t and this will become as to be minus minus. So minus omega t minus pi by 2. This gets cancelled out. Therefore, delta pi is equal to what, children? Yes, plus pi by 2 will be there. So we know that what is the meaning of this phase difference in the basics of the alternating current topic there we discussed. So I don't want to repeat once again here. Please refer that video. So now I can say that voltage leads the current. Voltage leads the current by how much angle, children? By 90 degree. By what, children? 90 degree. Or we can say that current lags the voltage by pi by 2 or voltage leads the current by pi by 2. So because of that, I can draw the phasor diagram. So since when compared to voltage, current is lagging. So when compared to voltage is leading, that is towards the positive axis. When compared to it is, if you are assuming that has to be origin. So when the current is at origin, just for understanding purpose I am telling, when current is at origin, it takes some a positive value. That means when compared to current, voltage is leads. This is the phasor diagram. And that angle will be pi by 2 is radian. Pi by 2 what, children? Radian. Yes. The another one, that is power loss, average power. Average what, children? Is a power loss in the inductor. So average power loss in the inductor. We know that generally, the concept of RMS value, that and all we already discussed. The time average, that is the average power for one complete cycle, I can take that has to be as a P bar, or that is equal to P bar, that is equal to what, children? Voltage into current. Therefore, voltage into current. Yes, in electricity we discussed formula for power, electric power, voltage into current. Therefore, I can write that as a P bar is equal to voltage is V naught sin omega t into current I is what, children? I am going to write in terms of cos theta. You just see that this is the expression for the current in terms of cos theta, because the whole term V naught by L omega is I naught. Therefore, here I am going to substitute for I, that has to be I naught minus I naught cos omega t. Minus I naught what, children? Cos omega t. So I can take out that time average bracket should be there. It should be the time average bracket. Okay. Time average, what is the meaning? How to do the integration process? That and all I already discussed in the previous video. So please kindly refer that for the continuation of the topic. So now please see that. P bar is there. The constant terms are taken outside. Therefore, minus V naught is I naught is taken outside. The remaining is what, children? Sin omega t into cos omega t. Multiply by 2 divided by 2. Then we can get what? 2 sin A cos A. That is nothing but sin 2A. So therefore, just do the mathematical work. So minus V naught I naught divided by 2. And this value is what, children? Is a sin 2 omega t. Sin 2 omega t. So this is the power equation. Yes, but we know that either sine function or cos function or sine multiples of that, we said that the time average value will be 0. So for this value, this will be equal to 0. Time average value will be 0. Therefore, I can say that the average power loss in the inductor is what, children? 0. Average power loss in the inductor connected with the AC circuit is what, children? 0. This is the important results, because we know that yes, in normal tube lights and all, they are using as a choke coil. Yes, that we will be discussed as a separate topic. But choke coil is used to control the AC current, which is more effective when compared to the normal ordinary resistor, where there will be a more power loss when compared to the inductor. So inductor is more preferable to control the AC currents or AC circuits, because their average power loss during one cycle will be what, children? 0. That is the one point. And another thing, we just see that the frequency of the this power term is 2 omega is there. But in case of voltage and current, there we get only omega only. But here frequency is what, children? 2 omega t. That means when the voltage or current completes, for example, I am drawing here a comparison between voltage and the power equation. When voltage completes one cycle, the voltage completes one cycle, then what will happen, children? The power will makes the 2 times of that. 2 complete waves it will produce. 2 complete wave it will what, children? Produce that. So therefore, in that case, the power will be like this. So that I am just roughly drawing the diagram, but it represents that since the frequency of the sine wave is that the power term is 2 times of the frequency of the voltage or current. Therefore, when voltage completes one cycle, the power term completes 2 cycle. Yes, these diagrams are very important for your understanding purpose. Okay, children. So yes, this is the comparison graph between voltage and the this will be voltage and this will be the power graph. Okay. So this is the complete information about AC circuit with inductor. Please, I hope that this will be very clear idea regarding the AC with inductor in exam point of view as well as in MCQ point of view also. Yes, kindly note down the theory, students.